This is Group 8. Our project title is Well Designed in Southern Louisiana Through Normal, Geopressured, and Depleted Zones.
The first thing that we did was collect data from 173 wells that surrounded our well using Sunris. This is a picture of the Excel data sheet with the information we gathered from the wells. The serial numbers and well names are cut out for confidentiality reasons. Well depth. We got the depth of the surrounding wells to figure out the drilling rate and to find the cost. We found out if the wells were directional or not in order to figure out if we should have a directional well or not. We wanted to see how most areas in the area were drilled along with looking at our maps. The spud and completion date. The spud date is when the well drilling process started, so we gathered the spud date and the completion dates of the wells to get an estimate of how long it will take to drill our well, which also gives an idea of rig cost. Time to drill. The time to drill is the amount of time from the spud date to the completion date. The rate. To get an estimated drilling rate in the area so we know how fast to drill our well, we calculated the drilling rate in feet per day and divided it by the depth by the time to drill. Perforations. Not all of the wells we looked up had perforations, but if they did, we got the depths and we will make our decisions on perforation depths based on this. Sand name at perf. To know what information is in, to know what formation it is in so we can have a guide. USDW. Underground source of drinking water info was collected to see if that was something we needed to consider. Hole size / casing depth. Casing size. Hole and casing size is very important data for us to have because we are going to copy this data from the similar wells to our well, which seems to be pretty standard from the data we collected. Casing depths. This information is helpful when drawing up our casing design schematic because the depths at which we case will be pretty similar to the nearby wells with similar depths. The casing weight varied a good bit, but we will use it to get a ballpark idea of what we should use. Sacks of cement. We wanted to be able to get an average of how much cement it takes to drill a well, and knowing how much cement we will need gives us an idea of how much money we will need to budget for cementing. Mud weight. Our mud plan will be strongly based on what the mud plan is from the surrounding wells.
This is a map of Sand A, the structure map for subsurface. This is one of the 7 target sands for this well. This was the only one I was able to include due to the other ones. They have confidential information on them. So this is the only one I was able to include. But the structure is generally the same for most of them. They're just at different depths. From this, we can see the structure of the sand and the location and the structure of the faults. Also, the faults are in brown. And we can see where the arrow is pointing as a proposed location is where the well will be drilled. And there's a couple of, we had some technical difficulties. All of the B's on there are supposed to be well symbols, but the email, when I emailed it to myself and all, it changed the symbols somehow, and I couldn't figure out how to get it back. So the B's are well symbols. This is a fault plane map of the same area, so we can see the contour lines for the faults, how deep they are, and which way they're dipping. The solid line is the fault A. That's the big fault in the area, and then the dashed line is a smaller fault B. So we can see that a lot of the wells around the proposed location are in the same fault plane of the fault A, and in the background we can see the contour line that's for the overpressured zone, which is on the next map. So this is a contour map of a wider area, showing the contour lines for the overpressured zone, which shows us where it'll help us in where we need to set our intermediate casing to not damage the formation or have well control issues. Again, the B's and the other symbols are supposed to be well symbols, but they messed up on that. And this is the same map, just with the highlighted wells are the wells that we got in our selection for the well data on the Excel file. So we gathered data from all of those wells in the area, and you can see again the proposed location, so the proximity of these wells in location to where we are. It's 147 wells We got all the data from that from Sunrise.
This is our casing schematic. We designed our casing plan and schematic based upon the previously drilled wells in the surrounding area. We gathered our data from Sonorous in order to estimate the casing depths and sizes of our well. We have a 36-inch conductor casing going to 200 feet, 16-inch surface casing to 3,000 feet, 11 7/8 intermediate casing to 11,000 feet, 9 5/8 intermediate casing to 15,000 feet, and a 5.5-inch production casing to 19,000 feet, which is also the total vertical depth of the well.
In order for us to come up with a cost estimate for our well, we are currently working on filling out an authorization for expenditure form, or AFE, which is shown. An AFE is a budgeting and approval form that will allow us to estimate our total drilling expenditures and later compare them to the actual cost at the end of the project. This form is divided into intangible drilling costs and tangible equipment costs. The intangible costs will consist of expenses like labor, fuel, and power, drilling mud and chemicals, cement and cement services, and other various costs. Will be a little harder to estimate, but we are in contact with a business partner of our advisor who has a broad range of knowledge on drilling costs. We are currently waiting to hear back from him with information on casing prices. As explained before, we have singled out surrounding wells in the same fault block as our projected well and have chosen similar data from these wells to estimate our casing design first. We have given this information to the business partner of our advisor, and he is going to let us know what he has for us by Wednesday of this week.
From here, we will continue working with Nate to get an estimate for completion costs, complete our final casing design and mud plan. We will also be meeting with our advisor to continue discussing our progress and final plan for the project.
Thank you.